Here is our pictures, and today we will talk about what is a district energy system, how can the district energy system help you to save money, or your clients save money, and also how a district energy system can help you get development project permits from the government or the local authorities or wherever they are. So as she already explained, the urban building energy use is about 75% of the energy use. In some cities like Hong Kong, it's 90% of the electrical use is from buildings. Of those buildings, 30 to 45% of the building's energy use is heating and cooling, as you can see here. 90% of the buildings that we have looked at have some kind of energy efficiency. Another way of saying that is that 30% of the energy in buildings is wasted, basically. So 27% of the total China electricity generation was heating and cooling of public buildings. And that market is expected to grow. So what is district energy? It's a way of centralizing the production of heating or cooling in a neighborhood or a community. So this can be something like a campus, which could be an academic, a university campus. It could be a hospital campus. It could be simply a district that has been identified as a single purpose district, like an innovation district or something like that. So we generate the waste heat, we generate electricity in many cases, and then we generate chilled water and hot water and ship that off to the buildings. So what are the benefits of that? In fact, as you can see on the left-hand side of the screen, business as usual wastes an enormous amount of energy. And that is really the source of the advantage of district heating and cooling, is that we capture that waste heat and we are able to reuse it in a number of different engineering ways to meet the same demand. So the result of that is that you have substantially lower total energy consumption, even though the buildings are using a comparable amount. The energy gets produced much more efficiently and consequently costs you less. So, and costs your clients less. So these are the benefits from district energy that we're looking at right here on this slide. And these are the ones that most of the governmental agencies and the people who permit you want to know that your project is able to do this. So you can help them to meet their energy efficiency goals. You can certainly help them to meet their carbon dioxide reduction goals. You use less water and overall consume less. And then 80% less usage of chemicals, in particular, less usage of ozone destroying chemicals that are typically used in air conditioning units. So we think that the combination of being able to save energy and money and make your permitting process easier is a big advantage. Now I'll turn it over to Oscar.
So this slide is to illustrate how district cooling is evolving around the world. So we can see that there are some regions, very dynamic regions like Latin America, India, Southeast Asia, and China. And so what we want you to retain from this slide is that China is a very dynamic region for district cooling, and there's still a lot of potential. So a lot of room for innovation and a lot of room to develop interesting projects. So in this slide, we show you our capacities, our different projects around the world. So ENGIE is one of the first operators in district cooling all around the world. As you can see, we have projects in all different continents, and so we are capable of providing solutions to our customers practically everywhere.
And I'll just add for him that it is one of ENGIE's great specialties is their ability to do projects in extremely complicated, physically complicated construction sites. So with this next slide, this is Ben again, what we're showing you is a tool that we have developed, which is available to anybody, especially to ULI members. And what this tool does, you'll see it's a little video. It enables us to go to any city in China and make an evaluation about the engineering feasibility of district cooling systems. So you can see that this plots out the energy use. The little squares that you see in here, in fact, are ranking the sites for their potential to be serviced by district heating and cooling systems. And what this does is look at the engineering and construction feasibility. It does not necessarily look at the overall project feasibility, but it's a way to help developers and to help governmental agencies understand what sites are possible and what sites are best suited for district energy, so that you can be able to understand whether your project will fit within that context or not. So this is an interactive tool. It works online, and it's available to anyone who wants to be able to use this to look at potential sites. I'll turn it back over to Oscar.
So another important idea that we're pushing at ENGIE is that it's not enough to optimize the generation side of the system. It's also important to have actions and to control the user side, which is the most complicated and challenging one, right? And so today we have different ways of piloting buildings. You can have either BMS systems or IoT. But what we're pushing at ENGIE is like to come up with a system that it's reliable and economically interesting. So BMS, for example, you cannot put, for existing buildings, you cannot put cables and sensors everywhere because from a financial point of view, it doesn't make sense. And IoT works pretty well in your house because if the system shuts down, there's no problem. But for a 100,000 square meter skyscraper, it can be a problem, right? So what we're doing right now at ENGIE is working with startups to help us create local networks that are smart enough so when they shut down, they kind of self-heal itself. And so what we're doing is like having each equipment to react and to behave like a Wi-Fi router, actually. And so if the equipment, so for some particular reason doesn't work or shuts down, well, the equipment nearby, it's smart enough to find another one, and the information it will keep flowing, actually. And so this type of system, we call it self-healing AI, and the possibilities are very large because it's not only about conveying information, but about the type of data that you can recover. And so the advantage of a system like this is that the data that you're gathering allow you to pilot the equipments, but also allows you to create a database that can help you do some predictive maintenance. And on the long run, what we want to do is that gather all this data and make the buildings smart enough so that they can regulate itself. So meaning, instead of having people playing with thermostat, the building on its own, it's gonna learn how to provide the best temperature following an occupancy rate, following the temperature at the outside temperature, and following the best delta T's that we need for a district cooling system. And so the building is going to provide the best possible temperature to have the optimal solution for the customers.
So that is our end of our presentation. Slightly less than the 15 minutes that we had planned, but we think that to remind everybody of the major benefits, district heating and cooling actually reduces the total amount of energy consumed. It actually also provides a much more efficient regulation of the temperature inside the building and the building comfort for the tenants of the building. And finally, a project like this enables the developers to have an easier path for permitting, and one which local governments will tend to support. And we can supply software to answer all of those needs. So thank you very much for listening. And we look forward to any comments or emails that you return to us.